Our objective 10 in practice test B is asking us to write names of any compound when given its formula. Notice that so far we have specifically categorized each objective one at a time, specialized. So for instance, in objective 5, they were all identical categories, binary ionic. In objective 6, they were all ternary ionic. 7 and 8 focused in on molecules with the prefixes, and objective 9 was all about acids. We can clearly see binary ionic, ternary ionic, molecular compounds, and acids, one objective at a time, separated. Now they're all put together in objective 10. We are being asked to identify what type of compound it is so we know what set of rules we use to name them. The tool for number 10, if you are stuck and can't figure out what set of rules to use, try that flow chart that we had created together. Is the first element in H? No. Are there more than 2 elements? Yes, there are. When there's more than 2 elements, we now recognize that to be a ternary ionic compound. Ternary ionic have polyatomic ions. This one happens to have 2 polyatomic ions. NH4 taken 3 times, PO4. NH4 is called ammonium. PO4 is phosphate. When ammonium hooks to phosphate, it does so by crisscrossing charges. Ammonium with its +1, phosphate with its -3. That's why we're seeing a crisscross of charge. We simply say the names of the 2 polyatomic ions. This is called ammonium phosphate. A ternary ionic compound containing more than 2 elements. Number 2, Cl8O. This compound is clearly binary. It's made of 2 elements. Therefore, I know it will end with IDE, the last name, oxide. To determine if it's binary ionic or binary molecular, I decide what types of elements are combined together. Chlorine and oxygen are both nonmetals. When a nonmetal hooks to a nonmetal, it creates a binary molecular compound. This is the time that we use our prefixes for binary molecular. The prefix for 8 is octa. Attach it to the name of the element chlorine, and the first name becomes octachlorine. The prefix for the number 1 is mono, and it must be attached to the last name, monoxide. This is octachlorine monoxide, a binary molecular compound. Number 3 definitely starts with an H, therefore I know to name it as an acid. Acids always start with H. So it depends upon the original ending on the negative ion. I need to find the name of a polyatomic ion called SO4. I know it will be a -2 because I have 2 hydrogens attached to it. Hydrogen's a +1, sulfate a -2. So when I go to the polyatomic chart, SO4 -2 is called sulfate, ATE. The rule says turn 8 to ic. 8 becomes ic, and we get sulfuric acid. We do not say hydro. Number 4, CrNO3. The first element is not an H, it's not an acid. There are more than 2 elements, so identify it as a ternary ionic compound. That contains a polyatomic ion. Still 2 names, although it has 3 elements. First element is Cr. It comes from the periodic table. Cr is called chromium. Chromium will require a Roman numeral. It lives in a short column. So I'll get that started by writing its first name, chromium. I'm going to leave a little space because I've got to determine the charge on chromium. Here's a group of atoms acting as a unit carrying a charge. We call that a polyatomic ion. NO3 is called nitrate. NO3 the polyatomic nitrate. Notice it is carrying a -1 charge. Therefore, working backwards as a chemical detective, chromium must be a +1 to balance the -1 and remain electrically neutral. Chromium 1 nitrate. Without the Roman numeral, we'd get it marked wrong. Number 5, ZN3P2. This is a binary compound. Binary compounds are made of 2 elements. The ending will be "ide." To determine if we hear prefixes, we decide if it's ionic or molecular. Zinc on the periodic table is a metal. A metal hooked to phosphorus nonmetal. A metal to a nonmetal is called binary ionic. We do not use prefixes. Zinc, although he lives in a short column, he does not need a Roman numeral because we know its charge is always +2. We simply say zinc phosphide. Zinc phosphide, a binary ionic compound.